Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and today we're going to discuss displacement ventilation. Like underfloor systems, which I discussed in a previous podcast, displacement ventilation systems came from Europe, where they've been used for quite a while. But in the U.S., they're fairly new to us, but they're gaining popularity, especially in schools. Displacement ventilation systems are defined by ASHRAE as a fully stratified system. This means that there's no mixing in the occupied zone. Looking at how displacement ventilation systems work will help explain why it's fully stratified. Let's draw a room in side view here and stick a displacement diffuser in it. In a displacement ventilation system, the supply air is brought in close to the floor and at low velocities. As the supply air travels across the floor, it displaces the warm air in the space, hence the name. Since the supply air isn't mixed with the room air, you end up with a stratified layer of warm air sitting on top of the colder supply air. But like in an underfloor system, this is okay because you don't want to pay to cool the air in the top of the room because no one's up there. Also like underfloor systems, because you are supplying the air directly to the occupied zone, the supply air temperature is warmer than what you use in an overhead system. If you remember from the underfloor podcast, this is because in an overhead system, the supply air has to travel across the ceiling and roll the room before it gets into the occupied space. So we use 55-degree air so that when it rolls the room and mixes with the warmer room air, it becomes a comfortable 75 degrees in the space. In underfloor systems and displacement ventilation systems, the supply air goes right into the occupied zone, so you don't need to start as cold. Displacement ventilation systems use 63 to 68 degree supply air to get that same 75 degree space. If you don't have to cool the supply air down to 55 degrees to dehumidify, this can result in energy savings. The low velocity is also important. In an overhead system, the face velocity of a diffuser can be 400 to 500 feet per minute. In a displacement ventilation system, it's usually closer to 50 to 90 feet per minute. Let's draw a room with the diffuser in side view. The cold air will slowly leave the diffuser and travel along the floor into the space. When the supply air comes in contact with a heat source, also known as a person or maybe a computer, the heat will cause the air to rise, and this convection plume lifts contaminants up and out of the occupied zone. This also pulls supply air up across the person, providing them with comfort and fresh air. For this reason, ASHRAE gives displacement ventilation systems a ventilation effectiveness of 1.2, meaning you can reduce the amount of fresh air that you have to bring into the space. This can result in energy savings as well. Now you still have to remember that ASHRAE recommends no greater than 50 feet per minute in the occupied zone, so you'll have an area that can't be occupied. Let's look at a room with one diffuser here up front. The area where the velocity is greater than 50 feet per minute is called the clear zone. This is very important, especially when you think about schools, which I mentioned are doing a lot of displacement ventilation these days. Let's finish the desk up first. You don't want the children sitting inside the clear zone, and you don't want the clear zone to be so big that you lose too much of your floor space. So if your clear zone is out here in the middle of the room, all of these people on the inside of the clear zone are going to be too cold. So this would be a bad place for your 50 foot per minute range. You also want to make sure that you're supplying enough air to handle the space. A good rule of thumb is to select the diffusers so that the furthest end of the space is about 15 feet per minute. One big reason that displacement ventilation is being used in schools is that it's a very quiet system. Studies have also shown a link between indoor air quality in a school and student performance. So maybe we'll get into some of those details in a future podcast. One drawback to displacement ventilation systems is that you cannot heat with displacement ventilation. You usually need a separate heating system with displacement ventilation. Let's draw a diffuser again. In cooling mode, the low velocity cold air falls out of the diffuser into the floor, but in heating mode it'll rise after it leaves the diffuser, kind of like this. In a future podcast, I'll go over Titus's solution to the displacement ventilation heating challenge. So what do displacement ventilation diffusers look like? They kind of look like perforated diffusers, but they're mounted in the walls. Titus displacement ventilation diffusers have adjustable nozzles behind the per face to allow control of the direction of the airflow. This allows you to make adjustments to the air pattern to make better use of your space. So let's draw a room real quick with a diffuser in it. And let's say our clear zone looks something like this. So it has a half round airflow pattern normally. Let's put a diffuser on the other side, but say we adjust the airflow patterns to point out left and right. Now your airflow pattern is going to look a little bit like this, where the air doesn't come out the center. And this is your adjusted pattern, which allows you to get a little closer to the front of the diffuser and use the space there. Okay, so that's an overview of displacement ventilation. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.